Geometry, Topic 3, Section 5, Example 2. We're asking the question, how many lines of symmetry does a regular hexagon have? We're going to just kind of draw these with the assumption that they would go through, there would be one going through the middle, and there would be going one through this side. I'm going to start with this side-to-side one. It's beautiful. It goes right through this vertices and that vertices. And just to keep this all straight, I am going to be using different colors. So with a regular hexagon, let's play with this just a little bit and see if there are perhaps other lines of symmetry besides just the ones that go vertically and horizontally. Okay, so this one we showed that this reflected horizontally. That totally worked. I wonder if we had through other vertices lines, would that work? So let's go ahead and draw through each of these vertices and check that. So using this one, I'm going to reflect it that way and line that back up, and we see that that did work. Let's try another vertices. And this one and this one. Okay, this I can tell where my original was based on my little markings. So this was where my purple was. So I'm going to try and reflect this way, and we see that it works. So now I've got those three lines of symmetry that will work for reflections. And we're going to go ahead and draw another one and see if this one works. And we can check this to see that indeed flipping it across this way totally maps it back onto itself. And I'm using a different color for each one of these because I want to be able to count them easier, and we get so many lines on here, it's a little bit more difficult to count. But we're going to, and you could construct these perpendicular bisectors through these sides to get perfect alignment. I am just kind of drawing these on here. We can check this one again if you want. Purple one reflects across, so that worked. And then there is one more, and hopefully you guessed that it is through the middle of the final set of sides. So for a hexagon, and it's hard to see the difference between the pink and the orange line on here, but you should be able to see that I actually have 1, 2, 3, 4, 5, 6 lines of symmetry. So a regular hexagon has 6 lines of symmetry. How do we know? That is part of the question on the try it. I want you to think about that as you pause your video and do the try it on the next page and answer that question. How many lines of symmetry, and how do you know when you found them all? So pause your video, try and figure that out, and then come back. For Try It Part A, there are 2 lines of symmetry. There is the one that goes horizontally through the middle, and I did not draw that very well. As we're constructing a perpendicular bisector or even measuring to find the middle of the line or of the sides would be beneficial. But just sketching this out, hopefully you see that there are 2 lines of symmetry. We go through the middle. If we reflect this way, we get the same shape. If we reflect this way, we get the same shape. Now, there is one other thing that you should be checking to make sure how do you know when you found them all? So you should actually be checking through the middle of each set of sides. So I should have gone through the middle, which is down just a little bit there. And then I should be going from vertices to vertices and checking that. So we're going to check this and see if that works. So as I line my shape up here, and it draws so much better on this paper with pencil, I want to be able to check to see if that line of symmetry works. So I'm going to flip that back around and line up that line. And notice that that did not map itself. So that's how we know that we found them all. We checked the middle of the sides and we checked the vertices. On part B, how many were there? Well, if you checked this line of symmetry or checked this line, it was not, that one did not work. Because if I rotate, if I reflect this one, right, if I reflect this one across that line, I will get this shape. So that does not work. If I checked vertices to vertices, again, I'm going to be flipping that shape here, and that would not work. But there is one that exists, and we will put that one on here in color so we see that one. And if we use this, it's easy to check. We flip it this way and line it back up. We have a perfect line of symmetry. So there is only one here, and there are 2 here.